Now you can hear me?
Yes, sir.
Yes. Okay. Basically, they asked us to discuss the last test. Did you look at the solutions which I have sent? Should I discuss these questions or anyone?
Sir, what are the portions for next OT, sir?
Speak loudly.
What are the portions for next OT, sir?
No, I can't hear you.
Sir, the portions for next OT.
Next one is 2D collision and then rotational motion.
Okay.
Just a minute. Then Okay, so this answers, should I discuss or not? These questions, the past test.
Yes, sir.
Okay, so I'll start the first question. So if you can read it, the simple pendulum, length 0.2 meters, has a bob of mass 5 grams. It is pulled aside to an angle of 60 degrees from the vertical. Spherical body of mass 2.5 grams is placed at the lowest position of the bob. Okay, when the bob is released, it strikes the spherical body and comes to rest. That's V1 equal to 0. 1 is the bob and 2 is the spherical body kept here. So after collision, the velocity is V. So V1, which is the velocity of the bob, is 0. Hello? Ah, hello? Take it there. Ah, ah, just a minute. Let's continue. So, okay. What is the velocity of the spherical body after it collides? So the first step is to paraphrase the question. That's like you have to draw a diagram and put the information given in the question in terms of symbols or like this. Okay. Once you do this, you'll be clear what is given and what you should find out. Okay. So first is we can find the velocity of this bob when it reaches the bottommost point. That's just before the collision. So before the collision, I can write the energy conservation equation between this point and the point when it's about to hit this bob. So at this point, the energy is the gravitational potential energy, which is mgh, okay, which is m1g. H will be this height from here to here. Okay, that has this height minus this height. This is a standard way of finding the height. So height from here to here, it's r. Okay, and if we draw a horizontal like this, so from here to here it is r cos 60. So this height from here to here is r minus r cos 60. Okay, so that is the loss in gravitational potential when it moves from here to here. That will be equal to the gain in the kinetic energy of this bob. That is half m u1 square. U1 is the velocity of the bob just before it strikes this spherical body at the ground or the lowest point. So from this, I'll get U1 because uh, R is given 0.2 meters. Okay, and the angle is given 60 degrees. So everything is known. So I can find U1. Okay, it's some number. G is 9.8. They're given the question as 9.8. So once you use that, you get root of 1.96. Okay, and this velocity or the mass with this velocity will hit this one. And after collision, uh, it's moving with the velocity. This 2.5 grams is moving the velocity V2, and this 5 grams is coming to this. That's given in the question. So we use momentum conservation just before collision, after collision. Before collision, the momentum is 5g into this velocity U1 because this is at rest. So this is the initial momentum. Okay. And final momentum is 2.5 grams into V2 because this 5 grams has come to rest. So from this, we'll get V2 as 2 times square root of 1.96 and 14 square is 196. 14 square is 100 plus 4 square is 16 and 2 times 10 into 4 that's 80. So it's 196. So 1.4 square is 1.96. So square root of 1.96 will be 1.4. So 2 times 1.4 is 2.8. So the correct option is option B. Okay, this is a simple question only. First, I use energy consumption between this point and this point to get the initial velocity of 5 grams before impact. And after impact, there will be momentum conservation. And after impact, he has said that 5 grams has come to rest. And this thing will be velocity V2. So using momentum conservation, we can get the velocity of this 2.5 grams after collision. Any doubts in this one? Simple question. The only thing is here, the height lost from here to here is the height from here to here, which is the height from here to here, which is r, and the height from here to here is r cos 60. So the height lost is r minus r cos 60. That's the height from this point to this point. That's the only thing you have to know in this question. Is this question clear? Is the solution clear? Any doubts? Anyone? Can I move to the next one?
Yes, sir.
Okay. Second question, two particles A and B initially at rest. So both U1 and U2 are 0, or UA and UB are 0. Move towards each other under mutual force of attraction. For example, this could be gravity. Okay. At the instant when the speed of A is B and speed of B is 2B, okay, the speed of center of mass. So initially the center of mass velocity I can find by using this one, m1 u1 plus m2 u2 divided by the total mass. Okay, and u1 and u2 are rest. It's given in the question. So from this I get the velocity of center of mass. Initial velocity as 0. And there is no external force acting on the system. It's just the internal force, which is the mutual attraction between these two. So acceleration of this center of mass will be 0. That means the velocity will not change. So whatever the initial velocity of this system, that will be same with the final velocity of the center of mass of this system. So that'll continue to be 0. Okay. This is something a trivial question. But we just have to realize the initial center of mass velocity is 0 because both are at rest. Since both are at rest, the initial center of mass velocity is 0. And the velocity of center of mass finally will be same as the initial center of mass because there is no acceleration. Acceleration is not there because there is no external force. This force of mutual attraction is the internal force, which will not affect the center of mass. It will affect the individual velocities, but not the center of mass velocity. So here the correct option is option D. Okay. Third question, 4 particles, figure is given. Okay, only thing you have to write the acceleration of 4 particles in vector form. Okay, 4 particles in the corners of a square, but the masses are different. Mass of A is m, B is twice m, C is thrice m, and mass of the D particle is 4 times m. Okay, and have accelerations. Magnitude is same, but directions are different, and the masses are different. So if you use the definition of center of mass, it's m1 a1 plus m2 a2 plus m3 a3 plus m4 a4. Only four particles are there. Divided by the total mass. So velocity of A, x-axis they are already thrown in the figure, so we can use that. So velocity is towards left, so it's minus I cap. B is upwards, j cap. C is towards right, I cap. And D is downwards, so minus j cap. And the mass are m, 2m, 3m, and 4m. So, and the total mass is 10m. Okay. M and 4m if you add, will get 5m. And then 2m and 3m will get another 5m. So it's 10m. So m will cancel. And if you collect the i's, it will be here, right? 3 and then minus 1, 2. And then j will be 2 and then minus 4, minus 2. So it will be I minus j cap by 5 into A. Okay, so correct option is option B. Any doubts? It's straightforward using the definition of center of acceleration, acceleration of center of mass. But the only thing is you have to put the individual accelerations in vector form because acceleration is a vector. Okay, and the mass are different. So to take that into account. Is this clear? Any doubts?
No, sir.
Okay. Next question, question number 4. 3 objects ABC, okay, kept in a straight line on frictionless horizontal surface, mass m, 2m, and m. Okay. Okay, object A moves with the speed of 9 meter per second, okay, and makes an elastic collision with 3m. So I put E equal to 1. So I put all the information in the question in this figure, okay, otherwise you'll make mistakes. The object A moves towards B, okay, that's what I said. That's initial velocity and makes an elastic collision. Okay, thereafter B makes a completely inelastic collision with C. So A hits B, and then B moves, and then B hits C, and the elastic collision is completely inelastic. Inelastic means E is 0. That means both of the bodies will stick together after collision. Okay, all the motion occur in the same straight line. Final speed of V. So we have to find VC. V stands for final velocity. Okay, so we can use the formula for the collision. I mean, velocities after collision. Just a minute. Uh, so this is the formula. Two bodies M1 and M2 colliding with initial velocity U1 and U2. Okay, it's 1D collision. And the final velocity V1 and V2 are given by this formula. Okay, so we can use this formula to get the final velocities. So here U2 is 0. U2 is 0. So V1 is the mass difference M1 minus M2 into U1. So M1 minus M2 is minus M divided by the total mass M1 plus M2, that's 3M. Okay, into the initial velocity of the first one, 9. So we'll get V1, that's velocity of this first mass after the collision as minus 3. So after colliding, it moves in this opposite direction. Okay, similarly, I can get V2 from here. Again, U2 is 0. So just twice M1, that is 2M divided by the product. So 2 by 3 of 9. So that is 6 meter per second. So 6 is the velocity of the second mass after collision. So from this I get the velocity of center of mass. Hold on. VC I can get. This is the okay. VC I can get from this formula. This for a partially this formula is for elastic collision. So E is 1 here. But for a inelastic collision, depending on the value of E, the answer will change. Okay. Here in the second collision, E is 0. Okay. And then both are sticking together. So if you put E equal to 0, I get M1 by M1 plus M2 into U1. U2 is at, this is at rest, right? So total mass is 3M and then M1 by the total mass. So M1 is 2M. Actually, in the second collision, the first mass is this one, 2M. Second mass is M. Okay. In the first collision, the first mass is M. Second mass is 2M. So in the second collision, the first mass is 2M. So here M1 stands for this mass 2M. So 2M by the total mass into the first velocity. I mean, velocity of the first mass, which is 2M, which is 6 that I found from here. Okay. And then this mass is at rest, the third mass C. The question should be given the question. Okay. So this U2 is 0. So from this I get the velocity of this C, the third mass, because this is actually I have to use this one. Second mass. Yeah, I have to use this one. Okay. So U2 is 0. So 1 plus E is 0. So 1 by the total mass into the first mass. I have to use this one because it's a velocity of the second mass, which is C here. Okay. So it's 1 by total mass into M1. 1 by total mass is 3M into M1 is this first mass 2M into the first velocity, U1. Okay. So that will give me 4. So the velocity of this third mass C after collision, after the second collision, first collision between this M and 2M, after that M will move this side because it's minus 3. and the 2m will move towards right by 6, and this 2m with 6 velocity will collide with this mass m, and this will start moving. That velocity is given by this formula. In that formula, you have to put E equal to 0, and m1 and m2 are known. M1 is this mass, and second mass is this m. So if you put, you'll get the answer as 4. So it's moving towards right with a velocity of 4. So option is option B.
Sir, can you please send that collisions 1D documents, PH collisions 1D,
Yeah,
that
yeah.
other.
Actually, it's there already. I sent the link.
No, sir, you didn't send it.
Okay, I'll send it.
Oh, okay, sir.
So next is this fifth question. Okay, so read the question. Two small particles of equal masses start moving in the opposite direction. So they're starting from point A, and one is moving towards right with the velocity of 2v, and another one is moving towards left with the velocity of v. Okay, in a horizontal circular orbit, that means it's like a circle drawn on a surface of a table, say. So gravity is vertical, so it will not affect the velocity. Okay, so just within collision, the particle move with constant speed. So there is no friction. So the speed will not change. So only during collision, something will happen to the speed. It's equal mass, right? So there will be exchange of velocities. Okay. After making how many elastic collisions other than that A, that's the beginning collision, these two particles will again reach point A. So this point A, the topmost point. So the one with moving towards left is moving with a lower velocity. Okay, so it'll travel a shorter distance. And the one moving towards right is moving with a velocity twice v. Okay, so we'll cover a larger distance. So actually it'll cover the distance twice. This will cover distance say 1. This will cover the twice distance. So the total distance we split into 3 parts. This thing will cover 2 parts, and this one towards left will cover 1 part. So 360 degrees, if I divide into 3 parts, it's 120, 120, 120. Okay, so this left, the one moving towards left will cover an angle of 120 degrees. By the time this particle towards right will cover an angle of 240 degrees. So they'll meet here. Once they meet here, they are two identical particles. So we will use the result that when two identical particles collide, elastic collision, after collision, the velocity will get interchanged. So this, the particle here will get the velocity of this one, that's v. Okay, and the particle here will get the velocity of this one, that is 2v. So this particle,
It's exactly 120 degrees, sir.
yeah, 360 by 3 is 120, right?
Sir, but then masses should be same and velocity should also be same, right, sir? Then only you can do that.
Here, velocity is the tangential velocity. It's a horizontal track, no? It'll move along the track. Okay. So actually, speed only we are considering because here the distance traveled is this curved distance. Okay, and the speed is v. Velocity means direction is constantly changing. Okay, so the one which is moving with v will cover, say, one distance, say s. The one which is moving with the velocity 2 will cover distance 2s. Okay, or I can say the one with moving with the velocity will cover an angle of theta. The one which is moving towards right, the velocity 2v will cover angle 2 theta in the same time. And this theta plus 2 theta should give me 360 degrees because they're going to meet. All right. So from there, I'll get theta as 120 degrees. Is that clear? Okay. So after this collision, so this one will get the velocity of 2v, and this particle will get the velocity of v. So this particle will travel a larger distance now. So it will cover 240 degrees, and this particle will cover a distance angle of 120 degrees. So it'll meet here. Okay. So while meeting this velocity, particle here will have velocity v, and this will have a velocity 2v. So 2v are represented by 2 arrows, higher velocity, and the one with velocity v as single arrow. So all these small techniques you have to use because it will help in thinking clearly and avoid mistakes. So after collision here, this particle will also pick up a velocity of 2v, so it can cover 240 degrees. By the time this particle covers 120 degrees, so it'll meet here. So in the third collision, starting from the initial one, they will meet again at the topmost point, point 8. So in the third collision, they'll come to point 8, beginning from the starting point. So option is, uh, third, they're about to collide. Option C, they are given 2. Let me read the question. After I'm making how many elastic pushes electron at A, 2 particles will reach again at A. Okay. So here they are coming. So it's coming after 2 collisions. One is here, one is here. So if you don't include this collision here, okay, just before that collision, they are meeting. So if I look at that way, then the number of collisions before it meets here is 2. I think they are given the key as 2. Okay. Fine. Is it clear? Basically everything clearly, and you have to draw the figure. So the one which is moving with velocity v will cover an angle of theta. The other one will cover an angle of 2 theta, and those two will combine to give me 360 degrees. So after 2 collisions, they'll come here, and just before collision, they'll say, we can say it's meeting. Okay, so the number of collisions before they meet again here, the topmost point is 2. Is it done? Okay, I'll move to the next one. Question number 6. A ball of mass 0.2 kg rests on a vertical post. Figure is given. Okay. A bullet of mass 0.01 kg traveling the speed of v in horizontal direction hits the center of the ball. After collision, the ball and bullet travel independently. So that means the bullet comes out of the ball. It's not stuck inside. The ball hits the ground at a distance of 20 meters and the bullet at a distance of 100 meters from the foot of the post. So the velocity of the bullet is. So in the vertical direction, one thing I can do, I have to get the time it takes to hit the ground. As far as the y motion is concerned, both the ball and the bullet are traveling the same distance. Okay. So if you use one of them and write s equal to ut plus half at square, in the vertical direction, the initial velocity is 0. Okay. So it is just half at square, that is half gt square. And the distance in the vertical direction is 5. And g is whatever, 9.8 or 10 that they are given. And then t I can find out. So I'll use g as 10. Okay. Then the time is 1 second. So it takes 1 second to travel this vertical distance of 5 meters. And both this ball and the bullet have initial velocity in the vertical direction at 0. So both will take the same time to reach the ground. So this is important information. So since once I know the time, I can find the distance traveled in the x direction, because in the x direction, the velocity will not change because acceleration is because of gravity. It's in the vertical direction. So x direction motion is constant velocity motion. This you're studying with projectile motion. Okay, in projectile motion, the x motion is easy to analyze because it's just a constant velocity motion. So if we know the velocity of this objects in the horizontal direction, I can find the distance covered. So velocity of the bullet, I have to find the velocity of the bullet. Okay, whatever is the velocity, that into time is the range in the horizontal, which is 100 meters. It's given in the question, and the time I have calculated, the time taken to cover this horizontal distance, same with the time taken to travel this vertical distance, which is 1 second. So from this, the velocity of bullet as 100 meters per second, because the distance traveled in the horizontal direction by the bullet is 100 meters. And that happens in 1 second. So from that, I get the velocity of the bullet in the horizontal direction as 100. Similarly, for the velocity of the ball in the time, which is 1 second, is the distance traveled by the ball in the horizontal direction, which is 20. Obviously, the ball is traveling slower. So the velocity of the ball is 20 meters per second. Okay. So I found the final velocity of the ball and the bullet. From that, I can get the information about the initial velocity of the bullet. This is using momentum conservation. Okay. So initial moment of the system is the momentum of the bullet because the ball is at rest. So initial moment of the system is mass of the bullet, 0.01 kg, into velocity of the bullet, capital B. And final momentum is both are towards right. Okay. So mass of the bullet is 0.01 into velocity is 100 and ball is 0.2, velocity is 20. So if I equate these two, I get the velocity of the bullet as 500. So bullet will travel at high speed before hitting 500 meters per second, and after hitting, the speed of the bullet has reduced to 100, and the momentum has been picked up by this ball 20, and ball velocity is less because its mass is heavy, because momentum is conserved. What is the initial momentum is the final momentum, and since this heavy mass is moving at a lower speed, it is carrying some substantial amount of momentum. If the ball of the if the mass of the ball is still further increased, this velocity will go down still further. So what is considered as the momentum?
Sir, is this collisions 2D series?
No,
This
1D.
model.
1D. See,
But here it is.
motion is 2D, but just after the collision and before the collision, it's along the straight line only.
Okay.
At the instant of collision, just after it, it's a straight line motion only. After that, it's a 2D motion, projectile motion. So collision is 1D, but after that, the resulting motion is 2D. See, 2D collision will happen if there are, I'm not able to draw properly, some wrong software. See, there are two spherical masses. Okay, some following software. Okay, and this has got a center and this has got a center, right? So I can draw a line joining these two centers. So the initial velocity of this one mass is along this line. Okay, after collision, this second mass will go along the same line, and this also will go along the same line, either towards the opposite direction. So everything U1, U2, V1, V2 are in the same direction. But if you have a slightly different thing, uh, first mass is like this. Okay, second mass is uh, like this. But this one, instead of, if I draw the line joining the two centers, it will be like this. But instead of this thing moving along this line, suppose it's moving slightly off, okay, like this, we'll go and hit this one, like this, at somewhat edge. This one, after collision, this mass will move like this, and the first mass will move like this. So here, U1, U2, and V1, V2, they are not in the same line because V1 and V2 have gone in different directions. So now they are in the same plane. So this is 2D collision. Okay, so the topmost point, if you read the question properly, it says your bullet traveling with velocity v in horizontal direction hits the center of the ball. That's basically to convey its 1D collision. You see the question? Traveling with velocity v, capital V, in the horizontal direction hits the center of the ball. So since it hits the center, it's like this. So it will be after collision, it will be 1D, 1D, because V1 and V2 and initial velocity V1 all in the same line. But if it is slightly offset collision, like this is called oblique collision, then after collision, the velocity will be different. This you got to watch in the carom board, because if you hit it straight, it will go straight. But if you hit it slightly, just like glancing the other point, then they will move in two different directions. So this is a 2D collision. Okay. So this is 1D collision only because it's hitting the center of the ball.
So 2D collision means after collision, they are not in the same line. They will go in a different deviation.
Yeah.
Okay.
See, this is 2D collision. Initial velocity, they have put as I. Okay. This in this X direction. Actually, they are drawn in a small mass. So if it goes and hits straight center, then it'll go straight. But if it is a, draw the picture properly, you can show that this is also 1D only. Okay, I send a picture. Basically, see, two spheres are there. I can hit the sphere directly at the center point, right? I can also hit it like just touching it. Okay, then the direction will be like this only. We'll go in two different directions. So this is head-on collision, center to center. Okay, after hitting this V1 will be the same line. This is like glancing collision or oblique collision. So this thing is not hitting this center point, but it's hitting this somewhere here. Then it'll go, after hitting this will go like this and this will go like this. This one. After hitting the velocity of this one, V1 is this direction, V2 is this direction. So now it becomes 2D because this V has got X component, Y component. This has also got X component, Y component. This is 1D collision because center of this thing is hitting the center of this one. So after collision, we'll go in same straight line. So this is 1D. That is 2D. Okay, 2D will do the next one. So it will become more clear. So here at the topmost point, the bullet is hitting the center of the ball.